just an introduction to friction, which you know a lot about. Our world works because of friction. Without friction, we can't walk, and we wouldn't be able to do pretty much anything, talk even. So you already know a lot about friction, which is great. And I'm going to start off with asking you 2 questions about your day-to-day experience with friction. Suppose you're going to move something really heavy, like a big heavy couch or a bed, something really heavy. Is it easier to get it started moving, or is it easier to keep it moving once it's going? So think about that for a moment. Moving something heavy, is it easier to get it started and then hard once it's moving, or is it hard to get it started and then it's easier once it's moving? So think about that. The other question I have is that if you have something like a lawnmower, is it easier to make it move across a surface if you're pushing on it or if you're pulling on it? So a shopping cart, a lawnmower, something like that. Which way is easier for it to push, for it to move, pushing or pulling? So think about those 2 questions, and we'll see what they have to do with friction. So think about those 2 questions, and I'm going to show you a quick little snippet of a simulation that shows the answer to the first one, which I think you already know the answer to. So here's a clip. So what we have here is a simulation where you can have a person, an object person, applying a force to a crate. And you'll see with 50 newtons, nothing's happening. The friction force is equal to the applied force. 100 newtons, same thing. 150, we just start moving. So once we've started moving, how much force does it take to keep it moving? Well, 100 newtons and it's still moving. So to keep it moving requires about 100 newtons, whereas to get it moving required about 150 newtons. And so we can see that it takes more force to get something moving and less force to keep it moving. Your day-to-day experience about friction has probably told you that if you're trying to move something really heavy, it's hard to get it going, but once you kind of break free of it, once it's moving, it's easier. And that's friction, and that's telling us something important about friction too. The other thing is that when you have a lawnmower, a shopping cart, something, if you're pushing down on it to make it move, that's harder to make it move than if you're pulling on a handle. That also tells us something about friction. So in our class, we're going to deal with 2 types of friction. There are other types, but the 2 we're going to deal with are called kinetic friction, and static friction. And if you think about those 2 words, static, when you think about static, well, besides like radio static, static often means holding still. That's how we use it, static equilibrium, for instance. So static means holding still. Kinetic. So a person who's kinetic is someone who's always moving. So a kinetic person is moving. So that's what kinetic means. Kinetic is the friction involved with movement, while static is the friction when something is at rest. So those are the 2 main types of friction that we're going to be dealing with. Now, based on the answer to that first question, is it harder to get something going, or is it harder to keep it moving once it's going? You should be able to guess which one of these is bigger. So which one do you think is bigger? Do you think kinetic friction is bigger? So when something's moving, it has a lot of friction? Or do you think static friction is bigger? When it's holding still, it has a lot of friction. If you think about your answer, you should be able to come up with the right answer to this question. So the way to think about it is, if it's hard to get something going, push, and then finally breaks free and it becomes easier, then it's easier to move it once it's going. Cats are very helpful today. That means that kinetic friction, moving friction, is less than static friction. So this is an important piece to remember. There's 2 types of friction. Static friction is bigger than kinetic friction. So it's hard to get something to start moving, but once it's moving, it's a little bit easier. So what does friction depend on? So I want you to think about, if you have 2 surfaces rubbing together, what could you do to make more friction between the surfaces or less friction between those two surfaces. So take a second, think about what factors are involved with friction. So take a moment. You probably have come up with a couple of ideas. When I do this normally with my classes, a lot of the ideas that come up are the weight. A heavier thing has more friction, and the surface materials. And another thing that often comes up is the surface area, so the area of the connection between the two materials. You might have come up with others. There might be more that I want to talk about too. For now, I'm going to focus on the first two. Weight is not quite right, but it's related to something. Heavier, you know from your day-to-day experience that the heavier an object is, the more friction it is. It's much harder to push a big couch across the floor than it is to push a chair. So weight is almost there. Surface material is definitely there. I mean, if you tried to move a couch across a shag carpet, it's awful. It's hard to do. Whereas if you tried to move it across nice smooth linoleum, much easier. So the surface material, definitely. Area, the surface area, we actually, at the level of friction that we're talking about, we're going to ignore surface area. It actually doesn't matter for how we're going to deal with it. It does have an effect on friction at a bigger scale, but for our purposes, we're not going to focus on area because it's really not a part, and weight isn't quite right. So what is it? Well, the surface material, we're going to have this new symbol. It's the Greek letter mu. So it's the Greek letter mu, which we pronounce it like a French cat, mu. So mu is the coefficient of friction. So mu is defined as our coefficient of friction. What does coefficient mean? Coefficient means it's a number. So coefficient is just a number of friction. So it's telling you how sticky a surface combination is or how slippery a surface combination is. Mu tends to be between 0 and 1. There's certainly friction bigger than 1, but everything we're going to see, it's between 0 and 1. And I would say that like 0.1 would be an icy surface, and moving that couch again around on a surface like shag carpeting would be up around like 0.8. So that's, I don't know how to call it, sticky. Doesn't want to move very well. So that's the coefficient of friction, and that's getting at this idea of surface material. Now, weight, I said it was kind of there. If we think about friction, if you're holding something up against a wall, and you're holding it up with friction, you know you have to push reasonably hard. You have to push reasonably hard to hold it up, because if you push lightly, whoop, it starts to slip. So that's not weight, although it's just the weight's pulling down, friction's pulling up. What really we're going to talk about with friction, instead of the weight, it's the idea of how much those two surfaces are pushing together. That's the normal force. That's the reactive normal force. So for the surface material, that is N, our normal force. And it's related to weight in most situations, but it isn't equal to the weight in every situation. So N is how much those two surfaces are pushing into each other. They're pushing in really hard, or they're just barely pushing. So with this, we can define the friction force. So friction force this is one of the simplest equations in physics. And it's also very fun. It's a fun equation. The friction force is equal to the coefficient of friction times the normal force. See, it's fun. This is the fun equation. And we actually have two versions of it. This is what's on the equation sheet, and this is what we use most of the time. But the kinetic friction force is the coefficient of kinetic friction times the normal. And static friction is actually an inequality. Because to get something moving, do I have something, well, to get something moving, you know you have to push a little bit harder than to keep it going. But if I just push a little bit, it's trying to roll off. If I just push a little bit on it, and I do this like this, yeah, it doesn't move. Push a little harder, it doesn't move. I have to push at least a little bit to get it going. So the static friction force can be anything from 0 up to this number right here, the coefficient of static friction times the normal force. Whereas the kinetic friction force is always just one number, because if you're moving, you're moving. It's not like the speed makes a difference. Nope, it doesn't. If it's moving, there is one friction force value. If it's not moving, the friction kind of reacts to the forces around it to be as big as it needs to be in order to keep at rest. So there's our basic fun equation. And I want to talk over two of the main errors people make when they're doing problem solving involving friction. So the two biggest errors that I have seen when students are trying to solve friction problems, the first is actually mixing up the friction force with the coefficient of friction. So F is a force. So that goes on the free body diagram or the force diagram. And this is in newtons, our typical unit of force. Whereas mu, that's just a coefficient. It is just a number. It doesn't tell you anything about a force. It is just a number. So it's just a number, and it actually has no unit because it is literally just a number. So there's no unit. So the biggest mistake I see is people mixing these two up, the force with the coefficient. So keep in mind that they're two different things. The thing that goes on the force diagram is the friction force. The other thing that I see people making a mistake on is always assuming that the normal force is equal to the weight. Now, in some problems it is equal to the weight. In many problems it isn't. And so you cannot assume that the normal force is equal to the weight. So do not make this assumption. You can't say that the normal force is equal to the weight all the time. So that's the other big mistake, is just automatically saying, oh, that's the weight. So those are the two biggest mistakes I see when people are trying to solve problems. An example that you experience probably quite frequently with the idea of static and kinetic friction is in a car. Now, I grew up in Minnesota, and this was before anti-lock brakes. And we're taught in driver's training to pump the brakes if you're skidding. So what you would do is if you start to skid, you don't go, what you do is you pump the brake, pump, pump, pump. So you just stop, 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 but you don't just keep holding it. What's going on with that? So that is what we were taught, but now with the anti-lock braking system, the car itself is doing that pumping. If you've ever had the anti-lock brake system engage while you were driving, you would feel a because that's what it's doing. It's pumping the brakes for you. It's going brake, 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 but not. So what is it doing? Well, if you think about a car tire rolling down, what kind of friction do we have? And this is a sneaky question. So let's say the car tire is rolling. Is this kinetic or is it static friction? Your first instinct is probably to say it's kinetic because there's movement. But this movement has to be between the two surfaces. Are the two surfaces slipping against each other? Is this bit of tire slipping against the road? Well, no, we don't want that. So normally you want static friction. That's the good stuff. So static friction is the good stuff because we don't want the tire to be slipping on the road. If it does, if it's not rotating, but it's just moving like this, if it's just going, that's skidding. And when you're in a skid, then the two surfaces are sliding across each other, and we have kinetic friction engaged. So in order to stop the skidding, we pump the brakes instead of just going, "Er." What are we trying to do when we pump the brakes? Well, we're trying to engage static friction and get out of the kinetic because, which one's bigger? Static friction is bigger than kinetic. And so by pumping the brakes, you're trying to just get, trying to actually get more friction to slow you down and brake safely. Whereas the kinetic friction is slower than skidding, you don't have much friction at all. And so the anti-lock brakes are taking advantage of this static friction versus kinetic friction. If you have cross-country skied, you know that there's the gliding parts and then there's the kind of grippy parts. And that's the same idea. You want different parts of the ski to be engaging either static or kinetic. So when you're gliding, you want that kinetic friction, and when you're like doing the, what do you call it, herringbone up a hill, you want static friction. So friction, you're going to see it in so many problems. I mean, most problems we're going to be dealing with friction because it's part of our everyday life. Almost everything we deal with has friction. So get used to that, and again, the two biggest mistakes, don't mix these two up. This is the force, this is just a number, and then don't assume that the normal is equal to the weight. And that's what I've got for friction.